So now that we understand what clustering is, let's use the R programming language as an example. So in order to do this, we're going to need to load in the library FlexClust. Now, R has several different libraries that can do clustering. I would recommend that we're going to combine two different libraries together because either one of them doesn't quite have all of the features that we want. So we're going to merge two of them together, and together they'll have everything we're going to need. So the first one is FlexClust. And the second one is k-means, but we don't have to load in anything special. That just comes with R. So we're going to use k-means, and we're going to also use FlexClust. So let's load in FlexClust. Okay. And also, because when you load in FlexClust, it has a lot of predefined data that you can use as examples. So we're going to use a data set called nclus. So we're going to load, and that's located, once you load this guy in, we get access to this guy. So we're going to load in this data called nclus. And if we type nclus, you'll see that it's a big giant matrix of just random data. But we're going to convert that into a data frame. So nclus is going to be as a data frame. So we're going to convert that guy into a data frame. And let's just run the head command real fast to see what the data looks like. And you can see there we have row 1, 2, 3, 4, 5, 6, and we have variable 1 and variable 2. Now, just for fun, let us plot this data, variable 1 and variable 2. And when we do that, you can see that there looks like there's about 4 clusters here. Now, later on, we're going to try to figure out how to know how many clusters there are, because in the real world, you usually are going to cluster with more than 2 variables. But in this case, we're just going to have 2 variables, and we can eyeball this. And these are compact, well-separated clusters. And you can see there's 1, 2, 3, 4 of them. So let's just say we magically know that there are 4 clusters. Well, how do you cluster using R? Well, the first thing we're going to do is we're going to use this command k-means. And we're going to give it this data set right here. And we're going to say that there's 4 centers, 4 clusters. Now also we're going to use this option here, nstart20. Now what does that mean? What that means is that R is going to go out, and if you recall from the previous lecture, if you get a bad starting point, you know how if we just randomly select starting points, if you get a bad starting point, you could get some bad clusters. So R is going to go out and try 20 random starting points and see which one works the best. So this is just going to give us a lot of different attempts. Now, it's possible that all 20 are bad, but it's unlikely. So we're going to just use this, and we're going to say k-means, and voila, we've just clustered this. It took just a split second. And if I were to run this command right here, size, it's going to tell us the number of variables or a number of records in each one of the clusters. So cluster 1 has 98, cluster 2 has 105, cluster 3 has 200, and cluster 4 has 170 in there, or 147. So let's also look at the center points. So what are these center points? The center points are the average of all of the people who are in these clusters. So the first guy is 7.9, let's call that 8, and negative 0.4. So 8, and that's about right here, and 0 is right about here. And you can see that that's probably the center point of these guys right here, or it's pretty close to it. What about this guy? 0.1 and 0. So let's go out here. Here's 0, a little bit more, and 0 here. Yeah, that looks like that's about a cluster. And what about here? 4 and 4. So we go right about here to 5, and right up about here. Yeah, that looks like a cluster. And what about the last guy? -2 and 6. So -2 is right around here, and 6 is right up here. So this guy's got about 4 clusters, and they seem to be pretty good. So now at this point, we are going to convert this guy right here into a flex cluster, which is a different library. Why are we going to do that? Because this guy here does not have a predict command. So we're going to want to eventually predict new data, just like we did with everything else. Unfortunately, whoever invented R didn't give us one of these. He didn't give us a predict command for k-means. So what we're going to do is we're going to take this guy and we're going to put him in to as KCCA, which is a data type inside of FlexClust. Now you're going to say, well, why didn't we just use FlexClust to begin with? FlexClust can also cluster, but the problem with FlexClust is that FlexClust won't tell us the cluster centers, which is kind of an important thing to know. And so for some reason, the guy who wrote this library didn't give us this command. So we're going to use this guy so we can see the cluster centers, and then we're going to convert him into a FlexClust guy. We're going to call him KF, and then we're going to use that one as a predictor. So let's do that. So this is the command that we want. And if I print KF, you can see that when I do this, that FlexClust says, hey, we got 98 guys in our first cluster, 105 in the second, 200 in the third, and 147 in the last. And if you notice, that matches perfectly with k-means. And the reason why I'm doing this is I'm saying, okay, well, we want to just be sure that when we convert, that it still works. I mean, that it's still correct. Now, I could go out and try to figure out what the cluster centers are for KF, for this FlexClust. I could do that, and this is the command or the code to do that. You convert this guy into a data frame, and then if I print this guy, let's just show you what it looks like. It doesn't look anything like the original data, but it does say that variable 1 is in group 2, and that's the value, and variable, he basically, if I type, let's just type the whole thing, KFI. You can see I've got a whole bunch of data here. And if I turn around and do an aggregate and say, would you tell me all the averages? Those are the averages right here. And just for fun, let's go back here and get the center points from the k-means guy, and you'll see that they match up perfectly. So if we use k-means, cluster 1 is 7 and minus 0.4. 7.9 minus 0.4. Cluster 2, 0.14 and 0.05. 0.14, 0.05. Next guy, 402, 403. 402, 403, minus 2 and 6. So the conversion process works just fine. Now, before we go and do any prediction, we can also do, with this guy right here, the flex class, not only does he give us a predict command right here, but he also gives us some cool graphs. So let's just see what we have available to us. So if I do BW plot KF, what does that look like? And what that does is it gives us a box and whisker plot for all of the clusters. And that can be kind of useful here. So you can see here that cluster number 1 has very low value for V2 and a high value for V1, and cluster 2 has about average for both of them. And you can just sort of see how these all work out. So that's kind of a neat thing. If you've got lots of variables and lots of clusters, it may not be as useful. We can also do an image of the cluster and look at any two of the variables at the same time. Now, in this case, we only have two variables, so there's not a lot to really look at, but we could do this, and it kind of is a nice way of looking at the clusters. Let's do that. And so what this is going to say is variable 1 is over here, variable 2 is over here, and you can see that this is cluster 1, 2, 3, and 4, and you can see sort of their boundaries. So this can be kind of an interesting way. If we have lots of variables, then you would have to print this several times, but we'll look at that with the next example. But here happens to be my favorite one, which is a bar plot. So if I do bar plot with KF, let's see what we get. This is kind of nice because you can see a nice bar plot of all 4 of the clusters. So you can see here that for cluster 1, big value for V1, V2 is close to 0. Cluster 2, they're both close to 0. Cluster 3, they're both large. Cluster 4, negative and a positive. So it's a really nice way of looking at all of the clusters. Okay, now let's take a look at the, well, let's just do it like this. Let's go plus. Let's just do a prediction. So if I take this guy right here and put him in KF, and then I put in my data frame, and I do a predict command, it's going to predict where everybody is. And if I type plus, look at those are all the predictions. Well, it might be more useful for us to assign that into our data frame. So let's do that. So we're going to create a new variable called cluster, and we're going to shove all that data in there. And if I were to say head data frame, you can see here's the first guy, and he's minus 0.2 and a 0.4, and he's in cluster 2. So cluster 2, and that probably is correct. Why don't we just go and let's do that image guy again, which is just for fun. So this guy here is negative 0.2 and a 0.4. So negative 0.2, that's about right here, and minus 0.4, which is right around here. Look, he's in cluster 2, exactly as you would expect. Let's do the tail command just for fun. Tail data frame. And you can see here that this guy is a 4 and a 4. Okay, 4 and a 4. He's in cluster 3. It makes sense. So there you have it. And we can aggregate this stuff, and we're going to say let's take these two variables. We're going to take the cluster, and let's take the average. And if you look at this, you're going to see that these are the same averages as we had calculated before. So the cluster centers are just the averages of all the guys in that cluster. See, 0.7, 1, 4, 4, and -2, 4. See, there they are. They're all the same. Now, one last thing that we're going to do. Remember, we did this prediction here, and we assigned that to the data frame cluster. We put it in there. Now, just for fun, if you recall when we first started off, we plotted the original data. So let's pull that up. And there it is. Now we're going to plot it again, only this time we are going to color it based upon the clusters. So now we're going to say color it by the clusters. Now watch this. There it is. Now, hopefully none of the viewers here can't see colors, but these guys are all blue. These guys are all green. These guys are all red, and these guys are all black. See, it clustered them successfully. So this is an example, a very simple example of cluster analysis. In the next example, we're going to use some real-world data, which will be our friend the IRIS data set.